So in order to prepare for this test, we want to go over several different things from this chapter. So first of all, we will review exponents. That's the first 6 questions and working with exponents, and then we'll move through this test in several different videos. So as we go over these rules, we'll talk about the rules first, and then we'll use them throughout these first 6 questions. I know that the directions keep changing, but they're really all the same idea. To simplify, and your answer should contain only positive exponents. So let's take a look at some of the rules that we have talked about. The power times a power. What we want to do is we want to add the exponents. A power times the power, we add the exponents. Here's an example, x to the 7th times x cubed. We have to add the exponents. It's going to be x to the 10th. Next, we have a power divided by a power. And this is, notice in all these we're talking about the same base. All these different powers will have the same base. So x to the 9th divided by x to the 5th. We will subtract the exponents. So that's going to be x to the 9 minus 5, which is x to the 4th. Next, we have a power raised to a power. And we're going to multiply the exponents. So you see that is when a power raised to a power, x cubed, the whole thing to the 5th power. We're going to go ahead and multiply that exponent, so that would equal x to the 15th. And then the last one, which is one that probably struggle with most, has to do with negative exponents. So a power with a negative exponent can be moved up or down. So when I say it can be moved up or down, that's talking about numerator and denominator. So if it's in the denominator, it can be moved up, or if it's in the numerator, it can be moved down, as long as you change the exponent to positive. You have to change the exponent to positive. So I'm going to put a couple examples of where we see this. So if we had x to the negative 4th, well, in our mind, we know x to the negative 4th is over 1. So I think sometimes we forget that is actually a fraction. So that can be, that x to the negative 4th can be moved to the denominator, can be moved down, as long as we change the exponent to positive. So what's left in the numerator? Well, it's a 1, because this is like 1 times x to the negative 4th, so we have 1 over x to the 4th. That's one case where we see that. Another one is sometimes we actually see it in the denominator, so maybe 1 over y to the negative 3. Well, 1 over y to the negative 3, that's in the bottom. We know that can be moved up as long as we change the exponent to positive. Again, this is still a fraction because this is like a 1 here, but we don't leave things over 1, so this would just be y cubed. And then just so you see this happen in other circumstances, you might have like a 2, x to the negative 3, y to the 5th, over z to the negative 2. And we notice we have negative exponents, and we're not supposed to keep negative exponents. So the 2 remains the same. But the x to the negative 3, it's up, so we can move it down as long as we change the exponent to positive. The y to the 5th, nothing happens with that. And then the z to the negative 2 in the denominator, well, that's a negative, so that is down. It can move up as long as we change it to a positive. So that would be simplified there. So we're going to go ahead and take these rules and apply them to the first several questions. So as you work through here, first of all, we have several coefficients. And the funny thing is, sometimes we get mixed up with this. This is simply 2 times 2 times 3. And sometimes people will remember a power times a power you add. Well, no, this is just multiplication. There's not exponents here. So 2 times 2 is 3. 4 times 3 is 12. And then let's go to our x's next. We have an x, and remember, if there's no exponent written, it's to the first. And then we have another x, so we have x times x cubed. And then we have y squared times y cubed. So I'm going to kind of group those together. So this is an x to the first. So x to the first times x cubed, add the exponents, so x to the fourth. And y squared times 1y cubed. Once again, you add the exponents. A power times a power, you add the exponents, and that's y to the fifth. I know that's very small, but there you go. That's the answer for that one. Number 2 incorporates a power raised to a power. So we're going to multiply. And what we do here, we multiply 4 times each exponent. So this 4 is going to get multiplied times each exponent. But wait a second, this first coefficient 4 doesn't have an exponent, so it's an understood 1. So is k. This is k to the first. And so this looks a lot like the distributive property. 4 gets multiplied times each exponent. Please know that, times the exponent. So 4, and then 1 times 4. We're multiplying 1 times 4 is 4. K to the fourth, and j to the 3 times 4 is 12. You don't necessarily have to multiply out the 4 to the fourth, but I believe it ends up being 256. So if you want to multiply that out, 256, k to the fourth, j to the 12th. Moving on to the next couple. This we just have 4 over 3. They don't reduce at all, so we can actually just leave the 4 in the numerator and the 3 in the denominator since they don't reduce. And then n squared over n, well, this is division, so we subtract. So this is going to be n to the 2 minus 1. And so we're left with 4n to the first, or just n over 3. Number 4, kind of incorporating a few things here. Whenever we have numbers or variables without exponents, we can put a 1 in there, so that's 2 to the first times n squared. Well, we know a power to a power, you multiply the exponents. So this is going to be 2 to the 4th. And this is going to be n to the 2 times 4 is 8 over n squared. Well, now we have an n to the 8th and an n squared. Sorry, that denominator n looks so bad. So 2 to the 4th, that's 2 times 2 times 2 times 2. If you multiply that out, you get 16. And then this is division, so 8 minus 2, n to the 8 minus 2. So our answer is 16n, and 8 minus 2 is 6. Simplifying some more. As mentioned before, this is an 2 to the first. This is 2 to the first. This is x to the first. We'll be using those things. And once again, this looks like the distributive property of 4 gets multiplied by each exponent. So we have 2 to the 4th, x to the 8th. We actually just had that on the last one. Times 2 to the 1st times x to the 1st. Well, now we have a 2 to the 4th times 2 to the 1st. I know this is numbers rather than a variable in this case, but we still add the exponents. So we're going to add the 4 and the 1. So that's going to be 2 to the 5th. And then x to the 8th times x to the 1st. So x to the 8th times x to the 1st, we're going to add those exponents. So we have x to the 8 plus 1, which is 9. And that's our answer for that one. And then number 6, still the same idea. Simplify. Your answer should contain only positive exponents. We have a 2, really 2 to the 1st up here in the top, x to the 4th. In the denominator, remember this will be 2 to the 1st. And once again, this exponent on the outside gets multiplied times each exponent on the inside. And so we have 2 cubed. That's a 3 there. Kind of messed it up a little bit. X to the 3 times 3. 3 times 3, which is 9. And then y to the 4 times 3 is 12. Well, we're going to keep going. We have 2 to a power, and this is division. So I'm going to do it just using our rules. There are a few other ways to think through it, but just using our rules, this will be 2 to the 1 minus 3, because we're dividing, so we subtract. We'll do x to the 4 minus 9, because we're dividing, so we subtract exponents. And then in the denominator, we still just have y to the 12th. There's nothing to do with that one. No other y in the numerator to work with. So we have, so far, 2 to the negative 2. We're going to have x to the 5 minus 9, which is negative 4 minus 9, which is x to the negative 5, over y to the 12th. But remember, you're not supposed to keep negative exponents. So this goes to the rule about negative exponents. A power with a negative exponent can be moved up or down as long as you change the exponent to a positive. So we can move 2 to the negative 2 down to the denominator, so that's going to be 2 squared, because we have to change the exponent to a positive. The x to the negative 5, that can be moved down to the denominator as long as we change it to a positive. And then the y to the 12th is already in the denominator. Well, what goes in the numerator? I kind of mentioned this before. There's actually like a 1 times this up here, so it's just a 1. I do see many errors of people just kind of forgetting that it's a fraction and just circling this bottom part, but it's definitely in a fraction. You need to keep it there. So there are several examples of what to do when you're working with exponents.